In this video, I'm going to go through P2, Chapter 2 and Section 2.4, which is tangents and chords and their properties. And part of this is GCSE. So you're reminded of some of the circle theorems. These two in specifically, the radius and the tangent, they meet at 90 degrees. So they always make a right angle when the radius and the tangent meet. And then the other circle theorem is that the perpendicular bisector, which goes through the center, so basically the diameter, or the radius, so it goes through the center of the circle, and it will cut the chord, bisecting it, so cutting it in half, and it will also make a 90-degree angle with the chord. So this is the perpendicular bisector of the chord. It cuts it in half and it creates a 90-degree angle. And because it goes through the center, it is either a radius or a diameter if extended. Now, this is a quick recap, a summary of equations of circles, which we haven't actually done. We will do next week. But this is very basic, so I just wanted to go through it. This is the basic equation of a circle, and because there is no number added or subtracted to the x squared and the y squared, the center for this circle is 0, 0. So on the grid, it's the origin. And the radius is this constant number and square rooted. So the square root of 25 is 5. So the radius is 5. This is a longer equation. Whatever the number next to x is, and this is a -3, the center, the x coordinate, is the opposite of that. So it'd be a +3. And then I look at, this should be y rather than x. So let's put that here, y, that's better. So I look at this number, and it's a +4, which means that the y coordinate for the center is going to be a -4. So the center of this circle on the grid is the coordinate 3, -4, and the radius is going to be √8 rather than 8. So you always square root that number at the end to get the radius. And if you know that basic information, this section, you can do everything on this section. So let's have a look. The circle C has equation x minus 2 squared plus y minus 6 squared equals 100. So firstly, I will just put some basics. What do I know about this circle? Well, I know that the center has a coordinate +2 for x and +6. And I know that the radius of the circle is √100, which is 10. And then part A says verify that the point 10, 0 lies on the circle C. So of course this is x and this is y, and if this point lies on the circle, then it fits this equation. So I'm going to substitute x for 10, or 10 for x, and I'm going to substitute 0 for y, and I'm going to check. So this is basically 8 squared plus -6 squared, but 6 squared is the same thing really, because any number squared is going to be positive. And let's check that those two give us 100. So 8 squared is 64, and 6 squared is 36, and 64 plus 36 does in fact give us 100. So therefore lies on circle C. I've shown that these coordinates fit into the equation of the circle. And part B says find an equation of the tangent to C at the point 10, 0, giving your answer in the form ax plus by plus c. So I'm just going to create some space for me to write. Okay, so I'm going to just do a simple drawing just to visualize what's going on. So I have a circle, and that circle has a center 2, 6, and the radius is 10. Okay, and it has a tangent, and this tangent is at 10, 0 somewhere. I'm not drawing a grid. So there's a tangent here at the point 10, 0. And I want to find an equation of the tangent. Well, the tangent is a straight line, so we're thinking of straight lines. And I know that the radius and the tangent meet at 90 degrees, which basically means that those two lines are perpendicular. So if I find the gradient of the radius, I know what the gradient of the tangent is because it's perpendicular to the tangent. So the first thing I'm going to do is find the gradient of the radius. So I've got my two coordinates. Let's call this x1, y1, x2, y2. So the gradient is 0 minus 6, and it's 10 minus 2, so it's negative 6 over 8, which is negative 3 over 4. So that's the gradient of the radius, which means that the gradient of the tangent is a positive 4/3. And the tangent goes through 10, 0. So I have y minus y1 equals mx minus x1. And of course, this time this is x1 and y1. So y minus 0 equals 4/3 x minus 10. So this is y equals 4/3 x minus 10. I'm going to multiply by 3, multiply by 3. These cancel, so I have 3y equals 4 times x minus 10. 3y equals 4x minus 40. And I make it all equal to 0. I think that's what they said. So I'm going to subtract the 3y, and I've got 4x minus 3y minus 40. So that's the equation of the tangent. And I used the circle theorems, and I also sketched what I've got. And to be honest, it doesn't matter where you sketch the tangent. If you put it here, you'd still understand that 10, 0 is there, and this is from the radius to the tangent. So it doesn't matter where you draw it, but drawing a sketch just makes it more real. It's important to do that. Okay, and the second example. A circle has equation x minus 5 squared plus y plus 3 squared equals 10. The line L is a tangent to the circle and has gradient negative 3. Find two possible equations for the line L, giving your answers in the form y equals mx plus c. So again, what do I know about this circle? Well, I know that the circle has a center positive 5, because this is a negative 5, and it has negative 3. So x is 5 and y is negative 3. I also know that the radius is root 10. Whether I use it or not is a different matter. So the line L is tangent to the circle and has gradient negative 3. Okay, so I'm gonna draw just to visualize and see if there's anything I need. So this is my center, 5 minus 3. And there is a tangent to the circle. I'll put it here. And I know that this tangent, the gradient, is -3. So that means that the center, so from the center to the tangent, that's perpendicular, so the gradient of the radius is going to be a positive 1/3. Okay, so the line L is a tangent to the circle. Find the two possible equations for line L. Now you may ask, how could there be two possible equations for one line? Well, if I take the tangent here and I just create a parallel tangent over there, well, you can see that it will have the same gradient. So the gradient is going to be -3, and it is still going, that's the same line. The radius is extended to make a diameter that cuts. Okay, so you can have two tangents, the same gradient, but it would have a different y-intercept. Now, we don't have a point on either of these tangents to be able to find the equation of the tangents, and so we need to do that. And we're going to do that by using simultaneous equations, because this line, this diameter, cuts both. So I've got a simultaneous equation with the circle. So firstly, let's look at this this radius. It's the same line. I don't need, it's just extended, so it's longer, but it has exactly the same equation because it's the same line. So I have got a gradient of the radius is 1/3, and it goes through this coordinate, so that's x1, y1. So y minus -3 equals 1/3 x minus 5. So y plus 3 equals 1/3 x minus 5. I'm going to multiply everything by 3. So times 3, times 3, times 3. This is gone. 3y plus 9 equals x minus 5. And I'm going to make it in terms of x. I think that will make it much easier. So I'm going to add 5 and add 5. So that's 3y plus 14 equals x. So that's the equation of the radius or the diameter. And I'm going to substitute that in to solve effectively a simultaneous equation. I want to know the 2 points where the diameter cuts the two tangents. So I'm going to substitute into the x there. This x is now 3y plus 14. So let's create a bit more space. That's going to be a long question. So x, which is 3y plus 14, and then it's minus 5 squared, plus y plus 3 squared equals 10. So I've got my 14 minus 5, which is a 9. So I've got 3y plus 9 squared, which is really 3y plus 9. in a double bracket, and this is y plus 3 times y plus 3, and I'm going to put negative 10 equals to 0 because it's going to be a quadratic. So this is 9y squared, and this is plus 27y times 2. So that is 54, so plus 54y, and then plus 81, and then plus y squared. And this is plus 3y and another times 2, so plus 6y plus 9 minus 10 equals 0. So we get the like terms together. So I've got 10y squared. And then I've got plus 54y plus 6y. So this is plus 60y. And then I've got 81 plus 9 minus 10. So 81 plus 9 minus 10. So this is plus 80 equals 0. And this is nice because I can just divide everything by 10. And remember, you can only do this if it's an equation, not an expression. So I've got y squared plus 6y plus 8 equals 0. So that is nice. This is y plus 4, y plus 2. So y equals negative 4 and y equals negative 2. And I've got my equation for x. X was 3y plus 14. So x was 3y plus 14. So for here, x equals 3 times negative 4 plus 14. So 3 times negative 4 plus 14 is a positive 2. And for this one, x equals 3 times negative 2 plus 14. And that is an 8. And so my two coordinates are 2, negative 4. Remember, this is x, so that goes first. And I've got 8 and negative 2. So if I go back to my diagram, one of them is 2, negative 4. It really doesn't matter, it's just a sketch. 2, negative 4. And the other one, what was it? It was an 8, negative 2. So 8, negative 2. So now I have a point that I can use to find the equation of the line, and the gradient is negative 3 for both lines. That's what I'm trying to find. Find two possible equations for L. So L1, we've got m equals negative 3, and let's use the first coordinate, this one. They want it in the form y equals mx plus c, so I might just use that. Y equals negative 3x plus c. This is negative 4. This is a 2. So negative 4 equals negative 6 plus c. I'm going to add 6 to both. Negative 4 add 6 is 2. So this is y equals negative 3x plus 2, or if you want to write it, y equals 2 minus 3x. That's also perfect. So that's line 1, and then, or L1, then this one is m equals negative 3 again, and it's going to be 8, negative 2. And I've got y equals negative 3x plus c. Y is negative 2. This is negative 3 times 8 plus c. Negative 2 equals negative 24 plus c. I'm going to add 24 to both. So this is c is 22. So the second equation is y equals negative 3x plus 22, or let's put 22 minus 3x. So the trick here is to solve the simultaneous equations, or create simultaneous equations to find the points of intersection between the diameter and the two possible and parallel tangents. Okay, so the points P and Q lie on a circle with center C, as shown in the diagram. The point P has coordinates -7, -1, and the point Q has coordinates 3, -5. M is the midpoint of the line segment PQ. The line L passes through the points M and C. Find an equation for the line L. So, we know that line L passes through M, the midpoint, and we can find the midpoint of the chord. We also know that we can find the gradient of the chord, and that the gradient of the chord is perpendicular to the diameter or the line L. So I think the first thing I'm going to do is I'm going to find the midpoint. So the midpoint is x1 plus x2 over 2, y1 plus y2 over 2. And I have got -7, -1, and 3, -5. So I can call x1, y1, x2, y2. And you've got -7 plus 3 over 2, -1 plus -5 over 2. So you've got -7 plus 3 is -4, divided by 2 is -2. And -1 plus -5 is -6, divided by 2 is -3. So that is the point M. I can also find the gradient of the chord. And of course it's y2 minus y1 over x2 minus x1. I'm going to use the same. So -5 minus -1 over 3 minus -7. So this is -5 plus 1, which is -4. And this is 3 plus 7, which is a +10. So this is a -2/5, which means the gradient of L is perpendicular to that. So it's a +5 over 2. And now that I have the gradient and the coordinate that the line passes through, I can find the equation of the line. So for this section, this is x1, y1, and I'm going to use y minus y1 equals m brackets x minus x1. And I've got y minus -3 equals 5 over 2 x minus -2. So this is y plus 3 equals 5 over 2 brackets x plus 2. I'm going to multiply everything by 2, so times 2 times 2 times 2. These cancel. 2y plus 6 equals 5x plus 2. Going to multiply the bracket by 5, so this is 5x plus 10, and this is 2y plus 6. I can't remember, they want it in a particular way. No, they did not. So, okay, equals to 0, 5x minus 2y. I'm going to subtract 6, so 10 take away 6 is a positive 4. And that's the equation of line L. And part B says, given that the y-coordinate of C is negative 8, so for C, the center, you've got x and negative 8, show that the x-coordinate of C is negative 4. Okay, so we know that the line L also passes through C. So if I know what y is, they said y is negative 8. Just check. Yep. So I can substitute y into the equation of the line, and I should get the value of x. So 0 equals 5x minus 2 times negative 8 plus 4. So it depends what you put in your calculator. If you put the whole thing with the negative 2 times negative 8, you're going to get a positive 16. And if you just put 2 times negative 8, you'll get a negative 16, but you'll have a minus and minus 16. So I would substitute negative 2 times negative 8, positive 16 plus 4. So 0 equals 5x plus 20. So this is negative 20 equals 5x. And I divide both sides by 5. X is negative 4. So I now know that the center of the circle is negative 4, negative 8. And I think this was the first question. Oh no, it was just B, and then there was a C. Okay, there's a C. So find an equation of the circle. Okay, so I know what the center is. And I need to find the radius. And have I got any information about the radius? No. But I do have information about the radius on the diagram, and that's why diagrams are important. This here, for example, from the center to the circumference, that's a radius. And if I have both coordinates, I can find the length of the line. And the length of the line will give me the radius. And I'm going to use this coordinate, not the one with the two negatives. So 3 minus 5. Okay, so I need to find the radius first. So I'm going to use negative 4, negative 8, and 3, negative 5 to find the line. So x1, y1, x2, y2. And I need to use length of the line, which is really Pythagoras theorem. It's going to be x2 minus x1 squared plus y2 minus y1 squared. So I've got, of course, all in the square root. So 3 minus 4 squared plus negative 5 minus minus 8 squared. And I don't even need to do any more. I just put it in the calculator as is. So 3 minus minus 4, you can put just a plus if you want, squared plus negative 5 minus minus 8 squared. And it gives me root 58. Well, that is the radius. So the equation of the circle is going to be x. Since this is a negative 4, in the bracket it's a plus 4 squared, always a plus. Y, again, since this is a minus, then inside the bracket it's a plus squared. And it's always this radius squared. So the root 58 squared is going to be 58. So the equation of the circle is the center, and it equals the radius squared. So we found the equation of the circle. And this is the end of section 2.4.